To fight climate change, we designed MyTACC, which does deep learning for traffic analysis and climate control. In this day and age, climate change and global warming run rampant, and MyTACC is designed to tackle this problem by using the data collected from monitoring traffic and carbon emission rates from exhaust gases. MyTACC monitors traffic based on photos taken of the traffic at regular intervals. The data is then stored and sent to the authorities. Authorities may act based on the traffic data to reduce carbon emissions and ease global warming. Some future improvements to MyTACC include feeding a live video into the product, making the product into a webhook, or making the product into a web app for public use.
So now this is the demo for our project. First of all, we'll set a limit to the number of vehicles. As for now, we'll set a total number of 40 vehicles, in which it consists of 20 cars, 5 buses, 5 trucks, and 10 motorcycles. In our first block of our code, we'll be importing our packages that we need. For the second block, we'll define the detector. For the third block, we'll open an image in which we saved earlier in our system. In this case, it is highway.jpg. As this is our prototype, we'll be using images instead of videos. In the future, we'll be using videos. In our fourth block of our project, we'll use OpenCV to convert the image that we saved earlier to a NumPy array for our model to predict and visualize it. So this is how it looks like after it predict and visualize. After we predict the data, we extract the number of cars, buses, trucks, and motorcycles in our system. And as you can see, we have 37 cars, which already exceeds the limits we given earlier, which is 20 cars. And this shows a warning sign to our system. And this indicates that government needs to take action for the place to prevent environmental pollution.
So here's an extra stuff included in our project, and it's also related to machine learning. This is about how we obtain a graph which appears right below our project problem statement. It's a simple linear regression prediction of carbon emissions in the future. Right now, I would like to explain on how we make the predictions using TensorFlow. First, we get a dataset about carbon emissions from Kaggle, which is an online community of data scientists and machine learning practitioners. Then we use Panda to read the dataset. In this case, it's a CSV file. We didn't have time to restructure the data to fit in our model using an external app, so we use Panda to achieve that. In this step, we are removing unwanted data because we are focusing on our country only. Also, we restructure the data so it makes everything else much easier. Secondly, we define a sequential model, which is used to build models with simple stack of layers. In this case, we are doing a linear regression task, so we're defining one layer here. After that, we compile the model. We use a very common optimizer, the Adam optimizer, and loss function will be the mean absolute error. Then we feed our training data into a model with 50 epochs, and no value as our label. We didn't split our data to training and validation data because we are lack of data. Finally, we make our predictions by drawing a regression line on top of scatterplot. So here shows our loss during training. This is a loss graph, and here is the graph obtained. So that's all for our product pitching. Thank you and have a great day.